Will be presenting the key activity. So, introduction. In my experiment, I was going to test what is the horizontal throw with 7 different type of balls with all of different masses. So what I was going to do is like to see how far these balls will reach by throwing them with the same force. So in this experiment, I was going to see which one reached the furthest, depending on the force I put to them. In this case, it was going to be the same. So the catapult, or this thing I used, is what is shown in the photo. Like I was going to pull it by the distance. Like I was going to pull it like from the center, like 10 centimeters or 30, and I was going to mark it. So the methodology. In this experiment, there are 3 variables, which are mass, distance, and force, or distance from the center of the catapult. The tension. The independent variable is mass, the dependent variable is distance, and the control variable is force or distance of the catapult, the tension. So experimental design. So first I was going to measure the masses of the same balls. I can also like just look them on the internet, really. Then I will determine like the distance from the center or the tension of the catapult that I was going to use. In this case was like 10 centimeters and 30 centimeters. Then after I throw them all, I was going to mark how far every single ball reached. How I'm going to measure the catapult is by pulling it. I was going to throw in a degrees of 0 degrees and an initial height of 0.55 meters. In the distance, I will be counting the distance including bounces. I'm thinking that the ball with less mass are going to reach further, but let's see. So in the results, this is the distance from 30 centimeters, the tension. The one that reached the first was the futbolito ball, and the one that reached the least was the soccer ball. Yes. And in this one was like pretty much the same results. The one that reached the furthest was, or actually in this one was the racquetball, and continuing the wiffle ball. So in the results, I can clearly see that balls with less mass were able to reach further, but this logic like didn't make sense with the one of the ping pong, because it was the one that weighted the least and it didn't make it that far. I'm guessing it's because of the shape and also the air that was like frenarla. This was interesting to me, but at the end the answer was pretty much obvious, that the balls with small masses will reach further. So in conclusion, this makes sense. In this experiment was related the third law of Newton, that this law says that for every action in nature there's an equal and opposite reaction. The research says that if a force is applied to objects of different masses, The ones that have the least mass will accelerate more. This is given by the formula A is equals to force multiplied by mass. En Khan Academy states la aceleración es directamente proporcional a la fuerza e inversamente proporcional a la masa. Eso significa que si dejas que te empujen, mientras más fuerte te empujan, más rápido te moverás. Mientras más grande seas, más lento te moverás. During my experiment, this applied because the objects with less mass reach further. So with this experiment, I confirmed that what I thought was going to happen, that the balls with less mass will reach further, except by the ping pong and another exceptions, but of the most of the balls they did it. At the end, this is written by some formulas and already someone tested, but it's still fun. Make it by yourself, And is the bibliography. And thank you very much.